Hi everyone, welcome to the fifth video in the series on setting up your Mac for neuroimaging analyses. In this video, we're going to set up Git on our local machines as well as connect it to a remote repository. So let's get started. So to begin, let's go to Google Chrome and then to the Neuroscientist Read the Docs for Git. So before I get started, I want to share a backstory. For the longest time, I was very intimidated by using Git. I would go on Github and see all these amazing repositories and functions and still felt that Git was somewhat of a black box. Fortunately, my partner is a software engineer and he showed me the ropes, and I realized how powerful and efficient Git could make my life as a scientist. It allows me to stay organized with myself. So if I have multiple versions of a manuscript, for example, I can put a little message that tells me what was different between version 5 and 6, and should I need to go back to a previous version, I know exactly which one I need to find the thing that I changed. So it is really great for me to stay organized just within my own kind of work station or workflow, and it allows for really great collaboration. So I could work on some code and I could do that kind of independently, and someone else can work on that code simultaneously, and then we could merge it and test it before we push it up to the main parent directory. So this allows us to work efficiently and collaborate with others while not having to email, the same scripts or slightly tweaked scripts back and forth. So I really love Git, and I hope that this video makes you feel more comfortable with using Git, and if you don't already use it, to give it a shot. So let's get into it. So what is Git? It's a version control system, which is basically something that records changes to a file. So if someone changes a file, so they either write to it or delete from it, Git records those differences between this new version and the old version and maintains that version history. So that allows a lot of people to collaborate on a certain project because all of the changes that people make are documented. And so this allows you to move back and forth between different versions and really see what changes each person is making to a piece of code. So Git has some really great documentation that you can check out by going here. There are some tutorials as well. So I highly recommend going through some of those if you want more experiences. And then the next part is installation. So before installing, it's important to see whether you have Git, because macOS does come with Git pre-installed, typically in user bin Git. So to do this, we can go to our VS Code that we installed in a couple of videos ago. And then here we can just write git -- version. And we see, there we go, we have it, so we don't need to install it. But if you did, you can use Homebrew to install Git using this command. So some important things to note. So how does Git allow us to work with others? The way Git is formatted is that you can have a main parent directory, so you might have some code on there, and I might want to work on that code, but I'm still unsure if the changes I want to make work and function as I want them to. And so I could have my own branch where I take that code that's in the parent directory, I pull it to a different branch, I work on that branch, and then when I feel comfortable, I push it to maybe a develop branch, and I ask my colleague, hey, can you test it out and make sure it's working? And if that colleague finds that it's working without any errors, then that colleague could be responsible for pushing it to the parent branch or merging it with the parent branch. So this allows multiple people to work on separate branches and to merge different changes that are made on different branches or with the main parent directory. So the nice thing is that if you do find an error, let's say I make a change and I even push it to the parent branch, and I realize, oops, something is broken, I can go back to a previous version. So all of that is kind of contained within this version history. So as always, we have our cheat sheet, And Git's cheat sheet is very handy dandy because I can't believe I just said handy dandy. Okay, well, Git has this really useful cheat sheet with the basic commands, which I'm going to go through in just a moment. So now what we'll do is create a Git repository locally and connect it with our remote GitHub account. So I'm going to assume that you already have a Git account set up. So I can show you mine real quick. Okay, there it is. And so my username is Hina-Minglani. So I'm going to come here and I'm going to write these commands to link my remote and repositories and my local machine. So I'm going to do git config -- global user.name, and then in quotes I'm going to put Hina-Minglani, and then I'm going to link it with my email as well. So user.email, and then this is not in quotes, so Hina.r.Minglani. Okay. So now this basically links our local machine to our remote GitHub account. And so the first thing I want to do is show you the two ways that we can basically connect the two. So one way is if you already have a repository existing on Git and you want to pull it down to your local machine, you can clone this existing repository. So the way to do that is go into your account and let's say I want to pull neuroscientist. I would go here and I would get the actual Git link, and so this will copy it, and then I'll come here and let's see, where am I right now? Hina. So let's say I want to go to documents and I want to go to my GitHub folder, and there I'm going to, this is where I want to clone it. So I would just paste that command I copied, paste it there. So there's no such file or directory. So let's see. Oh, whoops, I know why. So I had to write git clone and then write that. There we go. So it is all done. And so now if I was to ls, there is neuroscientist. If I go and change directories into that, so those are my docs. Those are all the things I have under GitHub and within that repository. So now let's say we have a folder on our local machine and we want to push it to our Git account. So the first thing you want to do is create a directory, for example. So where am I? I'm in neuroscientist. I'm going to go up to my GitHub account and I'm going to make a directory and I'm going to call it test. And then within that directory, I might change directory and I might create a readme.markdown file. Okay, and then I'm gonna see what's here. So that we have the readme. So let's go up, and now we see the test folder. The directory is created. Fantastic. So now I want to initialize the test folder. So I'm going to go back into test. See, I'm there, and I'm going to write Git Init. So we initialize this empty repository called test, and so it shouldn't be empty because we created the readme file, right? So let's do ls. Okay, so it does have the readme file, and so since it doesn't have anything else, I guess, we're going to take that readme file and, oh, so the reason why it says empty is because we initialized the repository, but it doesn't have anything on there in terms of the remote version of this. So we want to add this readme file to the files that are currently tracked by Git. So when we write git add, or maybe before we do that, let me show you what I mean. If I write git status, I can see that we have this readme file that isn't tracked right now by Git. So by doing git add, and we can just put the a dot there because that would just add everything that's there since the only thing we have is the readme file. Now we can do git status, and we can see, okay, so we have these changes that have to be committed. So those changes have been staged. So now I can do git commit -m. So I want to put a message, and I can just say created read me. Okay. So now it says, okay, we have a file that's been changed. If I hit git status, I can say, okay, you're on this branch. There's nothing else to commit. Everything is clean. Sweet. So now one thing that is important is you can see that this is called on branch master. And recently Git is moving away from using master and all of the negative connotations that might come with it. So we're going to rename this branch to main. So to do that, we'll write git branch -m and call it main. So the next step we want to do is we want to go to GitHub and we want to create a remote repository. So I'm going to go to GitHub right here, and I'm already signed in. I'm going to hit new, and then here I'm going to call this neuroscientist tutorial. Okay, and then we can put a description if we want to. So here we're just doing a Git intro. So this could be public. I'm not going to add a README file because I already created one. So we're going to hit create repository. And the great thing about Git is it tells you exactly what to do after this point as well. So we've already done these steps in our local machine. So the next step we want to do is we want to add this to our, link it with our local machine. So we'll just enter that here. Fantastic. And then we'll do Git Push upstream origin main. Okay. So basically what we did is now our local folder is linked to our So basically what that does is our local folder is linked to our neuroscientist tutorial repository, and we staged the commit to our remote branch that we had. So we basically pushed that commit that we made earlier to our main branch. Okay, so this is telling us branch main is set up to track remote branch main from origin. Sweet. So if we go here, we can go back to our repository, and you can see there's our README. Awesome. So let's say we wanted to edit that README and we wanted to make some change and write something about what we're doing in there. So one way to open up the folder that we're in currently is to write code -r dot. And here you can see that we are, here's our README file. So there, let's say we want to write, this tells the user what this repo is all about. Okay, cool. So then the next thing we want to do, if I go back to my console by hitting Control T, now I want to say I made this change and I've done it locally, and I can tell if I write git status that, oh, you know what? I didn't hit save. Let me hit save. All right. So now let's try it again. There you go. Okay, so I made a change and I have not staged this change yet. So to do that, I would write git add, and it says, okay, this change has been staged. What we can do is we can do git commit -m, and then the message could be modified the README. Cool. Okay, so let's see. So, okay, so your branch is ahead of origin main by 1 commit. So what this does is when we commit something, we tell Git, hey, I want you to take a snapshot of what this directory looks like right now. And then if we think this is good, we want to push it to our remote directory, we would write git push. So it's taking the changes to our README, and we can say git status to check that it did push them up. So it says your branch is up to date. So if we go back here and we refresh and we look at our README file, we see that it has been updated. So voila. Here we go back, and I've basically walked through these commands with you already. So basically the bread and butter commands are git status. Git status is great. It tells you what your local machine looks like and how it compares to the remote repository. So if there is a certain change that you've made, so if there's some modification, it'll tell you where that modification is. And then you can do git pull to pull a repository down. So if someone made some changes to this repository, I could write git pull and the name of that repository to bring it to my local machine. To add certain files, we've done that. To add everything, you can do git add dot. To stage the changes before publishing them, we write git commit and then -m just says, hey, I'm going to give you a message, tell you what I'm changing or what I've done. Note that the message that you add will be kept in the history forever. So you may not want to write something inappropriate there because anyone can go, if this is public, anyone can go back and see all of those messages that you wrote. You could make them fun though. It's always good to have an entertaining message to read. And then to publish those changes to your remote repository, you would use Git Push. And then finally, if you wanted to create a new branch and then move into it, what you can write is git checkout and then -b and the name of the branch. So let's say I wanted a develop branch. I would do that, and it says switch to a new branch develop. And then let's say we wanted to see what branch we're in, like we forgot. We could do git branch -a. And it shows you that we're in the develop branch. Let's say we want to go back to main. We could do git checkout main. Okay, cool, switch to branch main. So some final best practices. One of the most important things to do is to pull before pushing. So sounded weird. So you want to always pull from the branch that you're working on to make sure that you have the most recent version of the remote GitHub repository. So if someone makes some changes to a repository and they don't inform you by pulling, you will be able to bring those changes locally and see what they've done. And so this avoids any kind of merge conflicts. And if there are some merge conflicts, like you made some changes, someone else made some changes, by polling first, you can handle those locally as opposed to doing it kind of remotely. The other recommendation is to push only working code. So you always want to just push functional code to your remote repository so that when other people check out to your branch, the code is working. And kind of with that, it's a good practice is to keep main and develop as separate from your own branches. So always kind of pushing to your own branch, but allowing someone else to test that code before it gets pushed to develop or main is probably a good idea. That way you know that if you're changing this parent code, that it's been validated and tested by another. So you could use the develop branch for that purpose. So everyone makes changes on their own respective branches, and then they push them to develop when they feel like that code is functional and it's ready to be tested by another user. And then once it's tested, that could get pushed by a designated person to the parent directory or main. Okay. So that was an introduction to Git. In this video, we pulled a remote repository down. We also created a local repository or local directory and linked it with a remote repository. I walked through some of the bread and butter commands that we use when we're using Git. And most importantly, I hope that I showed you that these are some simple commands, just a couple of words that allow you to maintain the version history, which can be really, really useful for writing code and for even just keeping track of the various different files we produce when doing data science. So I thank you for watching this video, and I'm excited to talk about virtual environments in the next one. I'll see you then.